This is Breakthroughs, a podcast from Northwestern University Feinberg School of Medicine. I'm Erin Spain, executive editor of the Breakthroughs newsletter. Chronic pain affects 100 million Americans, some for a short period of time, others for a lifetime. Many rely on opioids for long-term management of pain, but this doesn't help them get better, and it could contribute to the current opioid crisis. Vania Apkarian, professor of physiology, anesthesiology, and physical medicine and rehabilitation here at Feinberg, leads a team of scientists focused on understanding pain. They've found that brain anatomy plays an important role in chronic pain, and they've discovered that placebos in the form of sugar pills can be effective treatments in some. Thanks for joining me today.
Thank you for inviting me.
How would you define chronic pain? Does it usually develop after an injury?
So chronic pain is a complicated issue, and it's been controversial for a long time. Its definition, in fact, waxes and wanes in different ways. The simplest definition is that pain that exists and you cannot control it. And in a sense, pain that's persisting more than 3 months overall, in general, we think of it as chronic pain. In more detail, essentially the way we think about it is that when you have an injury, for example, and the signs of the injury, the local inflammation and the tissue damage heal away, and yet the pain stays, then that's really a chronic pain condition. Now, there is a whole variety of chronic pain conditions that can happen any part of the body. And in many ways, its mechanistic properties have been highly controversial and hard to pinpoint.
You mentioned chronic pain can be anywhere in the body, but it often is in lower back. You see it?
So that's a good point. Low back pain, I was just reading it again yesterday, is the number one disability condition in the U.S. Considering all other health conditions, it is the number 6 disability condition worldwide. So the scale of the disability is massive. Fortunately, it doesn't kill people, but it definitely disables people. It impacts daily quality life. Of course, many people lose their jobs on account of it. And so it has a big financial impact on people's living. And it has a huge impact on healthcare costs. It is one of the leading healthcare costs in the U.S. Chronic pain itself is probably the leading healthcare cost. It's more than $500 billion a year of healthcare costs.
Right now, when someone has the chronic lower back pain, how is it treated? What do physicians do for them?
Since we don't really understand underlying mechanisms, we don't have scientifically validated treatment options. So at least the World Health Organization says that there is no treatment better than any other treatment for chronic back pain. And neither drug therapies, nor surgical procedures, nor alternative medical procedures, for example, acupuncture, exercise, all of those things are about equally efficacious, and we don't know who to treat with what.
So a lot of people are turning to prescription medication.
Yes, and prescription medication is very popular in large parts of society, although alternative procedures are also becoming popular, especially for chronic pain conditions. Yeah.
Well, how would you describe the current state we're in here in America with both chronic pain and now with drug abuse as well?
Right. Given that there is a huge number of chronic pain patients in the U.S. and worldwide, and given the large number of chronic pain patients who are treated with opiates in the U.S., the chronic pain population itself is a major source of opiate addiction in this country. It is probably the primary medical source of opiate addiction in the country. And yet the science behind opiate treatment for chronic pain remains uncertain. It may help some people. It may not help a large majority of others. On the other hand, both physicians and patients tend to use it, mostly because it has immediate effects, and those immediate effects, in many cases, has long-term non-beneficial outcomes, right? That people may end up having addictive type responses to the treatment.
This is a big motivation for you and the work you do to try to find a different way to manage this pain or maybe even cure it someday.
We definitely are involved in trying to understand what mechanisms underlie chronic pain. And in fact, my group of scientists in my lab have spent at least the last 20 years studying what are the mechanisms for chronic pain, and specifically what are the mechanisms for chronic back pain. We've concentrated on chronic back pain because it is the most common condition. And in fact, when we started studying chronic back pain, essentially nothing was known on the topic. So today, I can probably state that chronic back pain, compared to any other chronic pain condition, is probably the best understood chronic pain condition.
Thanks to your people in your lab and yourself.
Thanks to a lot of students who have spent lots and lots of years doing these studies, and thanks to a lot of patients who have volunteered in a lot of our studies over many, many years. So we've had hundreds and hundreds of patients volunteering in our studies. A lot of these studies have been studying the brains of these patients. We do brain scans in these patients and look at the properties of their brains and see what is different in their brains from other people, and then how their brains change in people when they move from an acute pain condition to chronic pain.
Let's dive into that a little bit. You were among one of the first to use imaging techniques on people's brains to start understanding pain. When was that? That was about 15?
That was before I came to Chicago.
Okay.
And so when I came to Chicago, we had just made the conscious decision that if we're going to understand chronic pain, we actually have to study chronic pain patients. It is something that still I go around, advocating in our scientific communities. And that, in fact, has been amazingly successful and fun. We have discovered lots and lots of signatures about chronic pain in the brain. And we can now say that the brain of people who have chronic pain is a different brain. Its anatomy and its functional properties have changed and have become the brain in chronic pain. Again, maybe not very surprising, because pain is always in the brain. It's a perception, it's a subjective state, and it's a negative emotional subjective state. None of us like having pain. Not liking having pain is a stress on the brain, and so that stress itself reorganizes the brain. On the other hand, we have also been able to identify risk factors for chronic pain. And risk factors is a big issue. It is something that, we are all very keen on discovering, because risk factors are exactly the things we can probably control down the line and identify specific therapy options for them. Risk factors from psychological viewpoint, from the injury viewpoint, have been studied for probably at least 50 years now. There are some risk factors along those lines, but they are small risk factors. Their prediction of outcome is relatively tiny. So yes, they influence the outcome, but they're not things that we are going to be able to target specifically. On the other hand, the excitement in our lab over the last 15 years has been that every time we have looked for risk factors in the brain, we have seen some very large effect sizes. And some of these things have now been replicated by other groups. We have replicated some of these studies back in animal models. And so we have quite a lot of confidence about what we are finding. And in fact, I'll make another plug about NIH. Just announced a huge, about $50 million proposal to make a very large study across the nation and probably worldwide to study the transition from acute to chronic pain, basically inspired by the research that we have done over the last 20 years.
Well, that's very exciting.
That's very exciting, but makes us even more busy because we have to write this grant proposal in the next few weeks as well. So.
Wow. Okay, you're busy. A lot going on in the world of pain. I want to backtrack a little to some of those risk factors, and then also what you are seeing in patients in the brain anatomy that's different when they are more subject to chronic pain.
So it's not just anatomy, but it is anatomy and function and anatomy in the brain go together, right? That's the brain function is defined by its anatomical properties. That's how we think and we we create culture, etc. Right? So it's all based on the anatomical properties and how those anatomy interact functionally with each other. So if we look at the brain of chronic back pain patients, for example, there are specific brain regions where the anatomy has changed, and we think it's reflecting the information processing deficits that these people develop over time with living with the stress of chronic pain. And in fact, we also show that many cognitive tasks that you and I can do, chronic pain patients have deficits on them. So those things go hand in hand. Both the anatomy, the function, and cognitive abilities are all interacting. And it's the stress of the pain, and as well as the coping. So any patient who has chronic pain has to create new strategies to cope with this thing that's there all the time, that's creating an interference to their anything that they have to do. It's very simple to imagine chronic pain state. For example, think of you walking on the street with a pebble in your shoe all the time. It's quite.
It grates on you, yes.
Yes, right. Yes, exactly. And so your personality is going to change, and you have to react to it, and you have to cope with it, and you have to live with it. And of course, different people have very different reactions to all of those things. And in many cases, yes, they suffer with this for the rest of their lives. So it's a huge cost to society.
Your latest study published in Nature Communications builds on a lot of your previous work, and you showed that you can actually predict which chronic pain patients will respond to a sugar placebo pill based on their brain anatomy and psychological characteristics. Tell me about that.
Right. So placebo is a really interesting topic, and people in general can respond to placebo. And this has been studied for more than 50 years. And in general, many other groups have actually shown the brain responses to placebo. So there is no question that it's a physiological response. And in a sense, one could simply think as an expectation and a consequence of that expectation process. On the other hand, the placebo properties, both in the brain and psychologically, has been studied for the most part in healthy subjects. The reason has been at least espoused was that that's how we can identify the underlying mechanisms. And there's a fair amount of research on the topic. On the other hand, why do we even care about placebo? Placebo is a strange thing. I'm giving you a sugar pill and saying, okay, your pain is going to go away. That's a strange concept. But there is a very long history in clinical trials of placebo response. So if you look at any clinical trial for any drug development, you have to have a randomized clinical trial where you contrast a placebo with the actual drug, and you want to make sure that your response to the drug is better than just the placebo. And of course, in every clinical trial, there's a placebo response. And not only that, in fact, if we actually look at the size of the placebo response, it is usually bigger than that of the drug. But of course, the drug has to become superior. So it has to just beat the placebo for the FDA to approve the drug for the specific condition that we're looking at. By and large, the scientific community had decided that this clinical trial-based placebo response is not informative, and it is simply a statistical artifact of clinical designs, and so it has no physiological interest. So we kind of tried to challenge that concept and in fact said, no, at least in chronic pain patients, where the brain is actually reorganizing specifically with the pain itself, these people these people have been subjected to the health environment for many, many years, either liking the health care that they're getting or disliking their experience. All of these things bring in a massive expectation of how they would respond or not respond to a placebo pill. And in that sense, at least in this population, these responses should be physiologically well-defined, predictable a priori, and in a sense they should underlie personality, psychology, behavior, and brain signatures that we should be able to identify. So that's the concept that we sort of started with, and this paper is in fact a confirmation that that concept had some bearing, and in a sense that we can identify a whole variety of brain properties before we expose the subject to anything that predicts down the line who will respond and how much they will respond to a sugar pill.
Who are these people? How are their brains different? And what about their personalities or their psychological profile makes them more likely to respond to the sugar pill?
So we specifically, again, studied chronic back pain patients because that's our expertise. We know the brain properties of these subjects best. And in fact, we relied on some earlier studies we had done, smaller studies that actually can guide us as to what properties to hone into. And so we recruited probably around, I don't remember the exact numbers, around 60 patients into the study. The study is relatively complicated. It's complicated to make it rigorous in a sense that there's an arm of no treatment at all where we bring people in and don't do anything with them. That's an observational no treatment arm that, in a sense, controls for the non-specific effects of the placebo. Again, from a classical viewpoint, one would have assumed that all placebo effects in clinical trials would be the same as the no treatment arm. So that's a control for that condition. And then the subjects are simply randomized into either receiving placebo or receiving an active drug. Before we do any of these things, we study their personality. We collect a whole variety of data about their personality and their brains. And then we simply treat them for a period of time. We take the treatment away to see if that would change their outcome, and repeat this multiple times. So this is a treatment that went on for about 6 weeks altogether. There are other complicated details that I will not bore you with. But by and large, in this study, we are looking at the properties of the brain, anatomical and functional properties of the brain, and personality properties, that all of which would be predicting before the subject is exposed to the pill, their outcome with the pill. But I should emphasize that the instructions we give to the patients is important, and in a sense we tried to replicate a standard randomized clinical trial design, just like every clinical trial where one is trying to develop a new drug and test its efficacy.
They don't know if they're in the placebo group or not.
They have no idea. Everybody is double-blinded. Neither the subject nor the experimenter nor the PI knows what subject is in what group. Moreover, the subjects are given completely neutral, the participants are given completely neutral instructions. So we tell them, you are going to be given a drug. It may or may not be efficacious for you, and you may be given either a non-effective drug, a placebo, and or a standard drug treatment. And that's it. And then we simply follow them in time and look at their responses. At the end of the study, we also ask the patients, the participants, what was your expectation? And then we compare their expectation with the outcome as well. That's also interesting because their expectation and the outcome have no correlation with each other in this case.
Wow.
Yes. So in a sense, unlike healthy subjects where we think placebo is primarily an expectation-driven condition, here we think it's being driven by their brain anatomy, by their personality, independent of their expectations. So in a sense, it's a concept that placebo is useful in these patients.
In this particular study, you did find that brains were different in the participants, and you were able to sort of pull out which folks you thought would respond to the sugar pill.
Right. That's the main point. That in a sense, both personality and brain anatomy and brain functional properties, the amount of information that these people exchange across brain areas, all of them are uniquely different between those who are responding to the placebo pill and those who are not responding. And let me spend a minute discussing the difference between the two. The ones who are not responding don't show any response at all. The ones who are responding, they have a pain relief of about 30%. That number is important because that 30% is clinically significant, and it is comparable or even superior to any drugs out on the market that we sell to these patients. So the efficacy size of placebo in the placebo responders is as good as any other treatment available on the market.
Including opioids and morphine.
Everything, all drugs out there. All drugs, all treatments, exercise, yoga, meditation, surgical procedures. They're not any better than what we are showing. So in a sense, just that fact says that in the future, when people are trying to develop treatments, they have to demonstrate that they can outcompete the placebo responders' placebo response. Okay, that's a little more complicated. It's not just the placebo response, because when you simply look at placebo response, this data shows 50% of people respond to placebo, 50% don't. Okay, so the placebo response in the population in general is 50% underappreciated. If you actually look at patients who are responding to placebo, it gives us a 30% pain relief.
Does this finding help put to rest some of the conversations out there about the placebo effect and some of the controversy about it now that you have some actual data to show?
Well, we'll see. I mean, society is complicated. I'm not going to say we have answered it and everybody's going to believe it, right? It takes time. Besides just the size effect, the fact that we can a priori identify responders versus non-responders gives us a very exciting pathway forward, right? And in fact, we're hoping in the next few papers we will actually show that perhaps we don't even need to do this brain imaging, because the brain imaging-based parameters can be mapped back to the subject's personality, psychology, behavioral assessment tools, and maybe they will be sufficient for us to identify placebo responders versus non-responders. And once we are there, then there is no reason why a physician cannot prescribe a subject a placebo pill and say, this pill, although it is an inert pill, will affect your psychology. You will respond to this pill. And in fact, I know how much pain relief you're going to get with this pill, given your response to this set of questions, for example. So that's the future we would like to go to. And that's a really exciting future because in many ways, it at least gives these patients a holiday from all these other treatments that they are exposed to.
With the poor side effects.
With all these
addiction.
Side effects, exactly. And in a sense, even if we don't know, for example, how long such a treatment would work, I suspect in time it will, wane away. We are not going to cure the chronic pain by placebo. It's not a cure. It is a psychological response to that pill. And so in time it should wane away, and then you have to replace it with something else. But even that by itself would give us a nice window within which I think it would be completely ethical and to actually tell the patient what you are giving them, and they should still respond to it because they have a priori all the anatomy and physiology behind it to respond to the procedure. And so that's the direct benefit to the patient. The other half of this is also the benefit to the whole industry of drug development. In a sense, we're pushing them to be more precise and to take into consideration that placebo response is a real event, and that they have to actually assess patients who are entering into the study as to whether they are placebo responders or not before they do any clinical trials.
and drug companies and physicians, for that matter, are more under the microscope than ever before with this opioid crisis that's happening in America. Can you just talk a little bit from your point of view about what's happened in recent years and what can the scientific community do to help rein this in?
Our position has been, and this is maybe it segues into this, our new grant that just got funded, has been that in fact, if you look at the brain properties that put people at risk for chronic pain and are predictors of chronic pain, they are the same brain circuitry that have to do with addiction to opiates. So, and that's a concept that we are actually pursuing both in animal and in human studies, and we just got funded for it. To start a center to specifically study the interaction between chronic pain and drugs of abuse, specifically opiate addictive effects on the brain anatomy, physiology, both in humans and in animal models.
This new center is funded by the NIH, first of its kind? It's
the first of its kind, and we're very excited. We just got the funding a few weeks ago. There will be more things happening. We're hoping to create the center and actually have an impact both from a science viewpoint, from a clinical viewpoint, from teaching, education, and engagement of patient population, patient involvement in our center, and hopefully come up with, the actual concept of the center is to develop methods and tools both to identify who are at risk, for example, for addiction, who are not at risk, and maybe is there a subpopulation that, in fact, can be treated adequately with opiates and they're happy and they're satisfied and don't develop signs of addiction, and while another group who are vulnerable and should be spared and not be given opiates. And part of the center is also to in fact, very aggressively develop, given the pathways and the mechanisms we know or we have discovered for the condition, alternative medicine. It's all in the pipeline.
Read more about Dr. Apkarian's recent discoveries at news.feinberg.northwestern.edu.